Assalamualaikum everyone. I welcome you all to the third day of the conference, and we are going to start off with a very interesting session on complex data set. It's going to be moderated by Dr. Waliullah, who's a professor at the School of Economics and Social Sciences. I invite Dr. Waliullah to please come on stage and introduce the other panelists.
Welcome to this session. In this session, we will talk about the complex economic data sets regarding big data, machine learning, and econometrics. First of all, I will invite my colleagues. First of all, Dr. Sajad, who is professor of computer science in the computer department at IBA, Karachi. The other panelist is Dr. Adnan Haider, who is professor of econometrics at economics department at IBA Karachi. And our third panelist is Fatma Sadiq, who is a faculty member at the economics department. This is a very unique panel. Here, Dr. Sajad is my teacher, Dr. Adnan is my colleague, and Fatma Sadiq is my student. So this is a very unique combination of this panel. Today we are going to discuss about the topic, the integration of big data, machine learning, and econometrics in the field of empirical economics. And this topic is not only timely, but also transformative. Nowadays, every click, every transaction, and every social interaction generates the data. We are in the ocean of information, and this is called big data. This big data, I'm not going into the concepts of computer science like the 3 V's and or 7 V's, but this data set is very complex, very rich, and very informative. Here we have data like, for example, the millions of, every day we have millions of tweets which are used to judge the public sentiments. Every transaction generates the data which give us some clue about the economic activity, tax collection, or consumption pattern of the economy. And we have sensor, we collect the data from those sensor, and those data is used in the field of environmental economics. But the main question is, how do we make sense of this data? How we are using this data set, this big data sets. So here the ML comes, which is a smart assistant, and help us to analyze this data set, which give us insights to find the patterns in the data which the human eyes cannot pick easily. And we use this data set in economics and finance for policy analysis, market prediction, and these type of things. We cannot deny the power of ML today. We can use this machine learning techniques, AI techniques to predict the market sentiments and make a good policy intervention to see the impact of this interventions on the macroeconomic variables. But if we see traditionally particularly in macroeconometrics, we were using the quarterly data or annual data, and we were only able to update our forecast quarterly or annually. But nowadays, we have a very large data sets. The data is collected on every point of time, and we can update our forecast daily or every minute. But the use of this machine learning techniques in the big data or econometrics in the big data also poses serious challenges to our analysis. Like, these machine learning models are called black box, or the AI machines are called black box. We cannot interpret. I'm not saying that it is a black box that we cannot compute it. We use statistical and mathematical formulas to compute the prediction, but it is very hard to interpret them for the economists or social scientists. The second thing is Like we have the GAN models, are the neural networks, the GAN models through which we generate the synthetic data in the case of small samples. So how much this data is reliable? And the third problem is, for example, in machine learning and AI, we use the data to predict the market. But if the, the data or the machine learning algorithm have not seen that episode in the data before, like we observed in the COVID-19, we were unable to predict the economic activity or macroeconomic variables through machine learning algorithms because there was no pattern in the data before that one like we observed in the COVID-19. So these are the challenges with the machine learning and AI, and particularly with our econometrics. But in econometrics, we use some like Bayesian estimation, so we use the prior information to make some forecasts. Now I am coming to my colleague, and our whole discussion will go around these topics. My first question is from Dr. Adnan. Dr. Adnan, nowadays we have big data sets and new tools in machine learning and data analytics. But what new insight do you think we have from this data analytics and machine learning have brought to the field of economics? And how these forecasts, how these methods are helpful for policy analysis and forecasting?
Thank you, Dr. Wali. Assalamu alaikum to everyone. This is really interesting question from your side, and let me tell you my own story. I basically did my undergrad in computer sciences roughly 25 years ago, and that was the time actually in the late 1990s. That was the area when actually the domain was actually getting momentum at that time. And I still remember when I graduated, I started my career in a software house in Lahore. And at that time, we used to develop AI-based applications, and the notion about artificial intelligence at that time, which we got training at that time, and that was different, but the notion and the ideas about artificial intelligence nowadays we have, because at that time we used to develop various applications, and those applications primarily based on expert systems, where we explicitly try to develop our applications and the solutions to many problems with many control structures like if-else conditions. For example, at that time, I remember we used to develop earlier chat box, and those chat box are based on like very similar to the Lisa software, where behind we develop the programming framework. Those are actually based on control structures. And the notion about artificial intelligence at that time, which is nowadays we used to call, label it as weak AI. And over a period of time, and especially at that time, especially in the late 90s, social media apps were not available. And at that time, computation power was not sophisticated. And at the same time, the storage cost was so high. So we rely on those earlier version of machine learning algorithms, which are not sophisticated to me, but we still use those algorithms. For example, I still remember ADA Boost algorithm was developed back in 1998, and those applications were based on ADA Boost based algorithms at that time, and we exploited those algorithms in our applications. And many of our applications at that time were based on various types of operation research type algorithm, where we use linear programming stuff, transportation models, dynamic programming applications. But at that time, the notion of intelligence was actually in a weaker sense. But over a period of time, especially in the last two decades, I myself observe the journey of the classic artificial intelligence towards the modernized version of artificial intelligence, which we are living right now. because in the last 2 decades, what we see the emergence of social media apps, for example, Facebook, Twitter, and many other things. And similarly, we also observe like the storage cost is now, it's very cheap right now. And at the same time, the emergence of big data and various other applications that were developed in the last 2 decades. So right now, since we have data with us, which is actually very large in nature, and primarily we economists actually assume like what we call data. So that is actually which is actually in the form of digits or maybe in the form of numeric numbers. But for CS people, they actually call everything data. For example, if we store images, so image is a type of data for CS people. Even video recordings, so these are types of data. Even the text, archive records, so these are actually data. So now we have huge data with us. At the same time, to gather information for meaningful analysis, so we need to develop various types of algorithms which are primarily focused on, and various other data analytics tools that can be used to extract information and try to learn from those patterns based on the data. So what we observe in the last 2 decades, the emergence of big data along with the data analytics. And since our economic applications, those are primarily based on data, so we actually as economists, so we actually try to use those big data analytics tools to address various kinds of alternative problems. And of course, with the emergence of big data, now the question is what sort of interesting ways and analytical tools which we need to develop and use to extract meaningful results from the data. For example, if the purpose is data mining, so in the past when I was actually young student and young expert in that area, so at that time we were using association-based rules to extract information and to summarize various things. But right now, the advanced version of machine learning algorithms are very important for us to get meaningful patterns from the data. So over a period of time, what I see like the massive development from conventional basic version of machine learning and now more specialized version of subclass of machine learning algorithm known as the deep learning algorithms, like the various types of neural networks. So we're going to exploit those algorithms to learn the patterns. So to summarize, that is important for us, like to train ourselves various types of data analytics tools to explore those big data. And important thing is we must have like economic problem with us, and we are going to address those economic problem and the social issues with the help of those data sets with the modern technologies. So this is the right time for us to use those techniques and to challenge our linear patterns. Like the conference theme is actually challenging linearity. So we economists mostly rely on the linear relationships, but at the same time, since now we have modern techniques with us, so it is the right time to challenge those linear relationships and let's think beyond those non-linear patterns to discover various types of economic and social relationships and to address various welfare-related issues, to address poverty, income inequality, and many other things. For example, recently I did very interesting sort of thing. I measured the poverty, that is a World Bank project, and for Karachi, and that is based on satellite imaging data sets. So we can use various machine learning algorithms to discover various interesting tasks. And since you already mentioned, if we want to use big data for various economic applications, then at the same time we need to understand the pros and cons. And of course, if we get very interesting training to tackle those problems which emerge with big data, so we can understand the relationship in a more better way. So I stop here.
Thank you, Dr. Adnan. My next question is from Dr. Sajad. Dr. Sajad, mostly we rely on neural networks and basically those large language models. And these models are basically developed for the textual data which can capture the long-term dependency in the data. But nowadays in economics and finance, mostly the people, here I have two questions. The first one is, in economics and finance, mostly the people are using the ADA boosting and bagging techniques to predict the time series data. Are these methods are reliable for predicting the time series? Basically, I'm understanding that these models are good for predicting the cross-sectional data, not for the time series data, but in economics paper, the people are using these bagging and boosting and regression type models to predict the time series. Secondly, these large language models were developed like we are using the RNN, LSTM, GRU, or transformer to capture the long-term dependency in the data. But the people are using these models are good for the analysis of textual data, but the people are using these models for the time series prediction. How much reliable are these forecasts? And secondly, are these methods appropriate to model the time series data in economics and finance, which I think do not have the long-term dependency? Only the 3 or 4 legs are enough to capture the dependence.
Assalamu alaikum and good morning, everyone. First of all, I'm grateful to Dr. Wali for such a generous introduction. He introduced me as his teacher, but I would say that we are colleagues, and whatever mutual respect and learning we have, it has always been both ways. Okay, so let me answer the first question. First question, the last question first. And being a computer scientist in this panel, I would take a more cautionary tone or view. So large language model or chat GPT is a new game in town. It's a very fashionable term, and people have so much expectation from these language models, but we need to understand what actually they are. They are nothing but text generation model. At least this is how the things started. So yes, if you give it a sentence, it can generate the next sentence. If you give it 3 words, it can generate the 4th word. So those of you who have background in economics, you are aware of Markov chain. And so if we did not have these large language models, we would be using the same task using Markov chain. But now, since we have so much data is available and we have these computing power, so people started utilizing all these huge data set and came up with deep learning based mathematical models which can generate the next text. But so the problem these models were initially trying to solve was machine translation, text summarization, keyword extraction, topic modeling. So this is their core competency, and I would call them a good, in fact a great technological disruptor. But we need to treat them just like Microsoft Word, Microsoft Excel, even social media platform. All of them are great, but all of them have their own limitations and comfort zone and a strong area, if we could call it. So if I start with MS Word and MS Excel, it has impacted all the fields. Even if you're a doctor, even if you're an economist, you're a statistician, physicist, everyone has gained benefit out of it. If you talk about social media platform, they had a huge impact. I mean, if you just look at the YouTube channels, so you would find videos from on all the topics. Same goes for Wikipedia. So in that context, LLM is going to help everyone. I mean, all of us are using it, on daily basis. In fact, I would say hourly basis. If I had the chance, I would have, posed Dr. Wali a question on ChatGPT and try to gather some summary of what it's saying. So in that aspect, everyone, they are going to be here, everyone is going to use them. But now, once we try to extend their, capability, then here comes the question, like, should we trust their output or not? So as I said, you can get a summary of any article, be it on economics, be it on statistics or computer science, but can I use it to do data analysis? And I would say no, it's not their core competency. Can I use them for situational awareness, for I would say analyzing complex data tasks, even for reasoning purposes? So even though they try to mimic something, they try to come up with an answer, but most of the time what they are doing is nothing but generating text, and this is the reason most of the time they hallucinate. So they may even produce information which doesn't exist, it's not factual. So this is what I said, people, the researchers, all of us are researchers. We have this habit of whenever something comes, we try to, we have this intention to try it and see if it works better than the previously known method. This is how research evolves. But I would say that, large language models, their main contribution is in the text domain. So we can do anything with the text data. But when it comes to dealing with mathematical, operations or analyzing numerical data, I would, sound a cautionary note. So that's the first thing. I hope I've answered this question. If there are other, follow-up questions, we can discuss later on. And your first question was about, applying, I just wrote it down, AdaBoost and I think other models for machine learning. So from the very beginning, so let me just, classify the data analysis problem in two branches. Historically, all the economists, all the statisticians, they were more interested in getting the inference part out of your data. So can we find a link between different predictors and target variables? How X is affecting Y? So this was the sole purpose of different fields, and people have been doing this for almost a century. Then machine learning came. So the earlier models, they were all parametric models. So you can define them in a very well structured form, and I can identify that if I change a unit in X, then this would cause a beta unit, a change of beta unit in Y. So this was fine, but then people say, no, we need to focus more on the prediction part. So somehow I'm not too concerned about the inference. I really don't care how X is impacting Y. What I need is a very accurate prediction of Y. And there we started developing all the black box models. So this is the term people commonly use, that all the new machine learning models they are black box models. They are good for prediction. In fact, they can beat any parametric model if you pass any kind of data set. So they are always going to outperform, because there is always a trade-off. Either you're going for accuracy or for expressiveness. And these machine learning models are more accurate in nature than the expressive part. So if we are dealing with this problem where our only concern is to make prediction, and we are not really interested in identifying the relationship between different variables, then I think it's hard to beat machine learning models. And this is what we are saying, like if you just go, if you just look at Daraz sale, perhaps they may not be too focused on what impacts what. They are just trying to optimize some of their ROI or some of the metric they have developed. Same goes for Food Panda, same goes for Kareem. So if our focus is on having a more accurate model, which can give us better prediction, then perhaps machine learning models are the way to go. But if like economic, like in the field of economics, even if you're in health data science, you need to understand the relationship between different variables. Then I would say that people are still relying on classical machine learning and econometrics based model, and it's not hard to replace them. I mean, it's not easy to replace them. So again, so there are mixed views, but I know I gave a very long answer. Just to summarize, that if we are focusing on understanding the link between our variables, our predictor variables, and the target variable, then we need to rely on econometrics and historical time series model, which were based on certain assumption. And this is why people used to check p-values and all the other things to see if the relationship really hold or not. But if you, and there was another perhaps historical reason as well. Like again, as Dr. Adnan was saying, 30 years ago, the data size we had was very small. Maybe people were working with 300 records, 400 records, 500 records, and in those data sets, the assumption you made were really important. And this is why we need to check the assumption first. Even if you are done with your modeling, you need to apply certain diagnostic to make sure that the model you have learned follows certain assumption. But this is not the case when you have large, huge data sets. So if you have million record, most of the things you have learned in classical statistics book, they are no longer required. So for instance, if I compute the p-value, if I just give you 300 records, then a variable may sound significant, or you may decide, okay, I need to drop it or retain it. But as you add more data points to the same distribution of data, then you will say, no, originally the point which I thought I should discard, the feature I thought I should discard, now it sounds relevant. So the P value now becomes significant, I need to retain it. So these are the things that will change our, application of these models. But most of the time, if we are focusing on prediction and we really don't, care about the interpretation part, the explanation part, then machine learning models are the way to.
Okay, Dr. Sajad. Fatma, my next question is from you. Fatma is working in the field of social network analysis and graph theory. So I'm asking about those fields. In today's intra-connected world, social networks have evolved, and we are using these social network models to capture the link between different nodes and edges, and we use different matrices. So basically, what are the main social network analysis matrices that we can use in economics and finance to model the economics data sets and finance data sets? So basically what is the social network analysis, and what type of matrices we use to model the economic data sets?
Assalamu alaikum. First of all, thank you for having me here. Okay, so answering the first question. So before we start talking about social networks, we need to understand what they are. And the simplest way to understand them is to realize that we all are part of one. So all four of us sitting here, we work in the same organization. So we are a part of a social network. Family trees represent social networks. Our Facebook friends group, they all represent social networks. So to formally define it, we need to understand two concepts. One is of nodes, which represent individuals, firms, countries, villages, etc. And we need edges to establish the link or relationships between them. So that's simply how a social network is defined. So for example, I'm looking at a village. So if two families or two households in a village know one another, so their relationship will be represented by an edge. That's simply how we envision or visualize social networks. Social network is a direct application of graph theory, which is a field in mathematics and computer sciences. Moving on, what kind of metrics do we use? So whenever we look at some raw data, for household data, for example, we're looking at PSLM, highest, or DHS. So we talk about summary stats, the descriptive stats, mean, median, and mode. But in network, the data is structured differently, so we need different metrics. So mean, median, these don't really make sense. So first of all, we convert the social network into an adjacency matrix. That's just telling us whether there is a link between two nodes. If there's a link between two nodes, there's one in that place, otherwise zero. So that's how a network is converted into data that can be used for analysis. Moving on, we have the concepts of degrees. So degrees are basically how many edges are coming out of a node or a vertex. So if I know 10 people, so there will be 10, my degree of my node will be 10, simply. Now moving on, we look at the probability distribution of a degree, and that's very important. It gives us the idea of whether the structure is homogeneous or heterogeneous. So if the degree is, distribution is very symmetric or uniform, so that means the system is homogeneous. Otherwise, it's heterogeneous. Moving on, we have centrality measures. Centrality measures just tell us how important a certain node or an individual is in a network. So for example, we have a boss in an organization, and to get to the boss, everyone has to pass through his or her personal assistant. So there is no way of getting to your boss without passing through the personal assistant. So the importance of that personal assistant is very high. So that will be measured by his or her centrality. Moving on, Networks are, within a network we might find very tightly knit groups, and those can be captured by clustering. So we have clustering coefficients that capture how tightly knit a group is within an entire structure. Furthermore, community detection, that's also a very interesting field and application of social networks. And that's important because within a network or within a community, you find groups that share common interest. So now, how we apply these concepts in economics or with economics data. So for example, I'm looking at trade data. Okay, so trade data from Comtrade can be easily converted into a network because we know about reporters and we know about the partner countries. So if two countries are exporting, they will have a link or an edge between them. So a country which is exporting to all across the world will have higher centrality. And to get an overall idea of whether the trade for that good is focused on only a few partners, we can understand that through looking at the degree distribution. Now, moving towards modeling, these are just basic descriptive stats. Even in econometrics, we need to move towards linear models, etc., to model a phenomena that we are studying. So what I have talked about are simply network statistics or metrics that help us look at a network. Moving on, we have exponential random graph models, which is a statistical class of models that help us understand what are the chances of this certain network to exist. And we have mathematical models in which we question whether the network that we are observing is because of a random process or there are certain economics or social factors affecting the existence of links within the community. So that's all from my side.
Yeah, okay, Fatma. My next question is from Dr. Adnan. Dr. Adnan, for causal analysis in traditional economic model, we were focusing on econometrics. We were modeling the econometric relationship. But when we start econometric, our model are based on the 5 Gaspar-Koff assumption. We start from the linear in the parameter and the error term normality. We are ignoring the remaining assumption, but talking about these two assumptions, linearity of parameter and the normality of the error term. But now we have machine learning algorithm which can capture the neural network, which can capture the nonlinear relationship. We have the big data, so we do not need, we can rely on the central limit theorem, which is the data is asymptotically normally distributed. So we do not need these assumptions anymore. So what do we think? Will the machine learning algorithm and AI will replace the econometrics? And if no, then what changes we should make in our curricula in the econometrics?
Thank you very much, Dr. Wali. So I think there are two parts in your question. So the first part already been addressed by Dr. Sajjad in a more nicer way, but let me add few cents to address that. You see, we economists, we always start with some theoretical foundation, and we used to develop various models by following that theoretical underpinnings. For example, we have some hypothesis, and then we develop the model based on that hypothesis. Think about Keynesian type of consumption function. So in order to estimate that consumption function, we develop the model, our consumption function based model, and that model is actually from econometrics foundation. So think about the consumption function in such a way where I have a simple linear regression that describes the consumption patterns, and for example, on one side you have consumption variable, on the other side you have absolute income, and the parameter which I'm going to introduce in that model to formulate that model, every single parameter in that relationship has solid economic foundation. Think about the slope parameter that is associated with the absolute income. We used to call this parameter as marginal propensity to consume. and similarly the intercept parameter in that functional form, in the linear functional form. So we used to call this autonomous consumption. So every single parameter we introduce in econometric model, it has solid economic rational and a solid economic foundation. On the other hand, when we start using machine learning algorithms in our economic relationships, so most of those algorithms, especially the emerging field right now, which is the deep learning, which is the subclass of overall machine learning. So in deep learning, as Dr. Sajjad already mentioned, every single algorithm, there are so many parameters just to find the relationship between two economic variables, consumption and absolute income. And those parameters are actually, we unable to basically label them, are unable to describe them. What are those parameters? Those parameters are basically just for the working of subclass of neural networks. For example, some parameter trying to control the forward mechanism, some parameters are trying to control the backward propagation, and some actually parameters are essentially used in deep hidden layers. But there is no economic rationale for those parameters in machine learning algorithms. However, in econometrics, whatever we formulated, they have solid economic rationale, solid economic foundation. So there is a trade-off while using both econometric model vis-a-vis the machine learning models. Now, to me, econometrics and econometric models are actually, I label them as, these are actually theory-driven models. And on the other hand, when we start using machine learning algorithms, so these are primarily data-driven. So these two are different approaches. So as Dr. Sajjad already mentioned, like if you want, if your task is to describe and analyze various relationships, and if you want to test various hypotheses, if you want to test various theories, economic theories, if you want to test various relationships, then of course econometrics is a very beautiful subject for us. Quantitative, it provides quantitative, solid economic quantitative frameworks to proceed this task. On the other hand, if your task is just to find the predictions, to find the learning patterns based on the data, let the data speak itself, so then of course machine learning algorithms are very sophisticated, they are very popular, they are very important for us to use those algorithms. Now, the second part of your question is which route we need to follow right now, because there is a huge development in both the fields. And remember, in the past, we economists actually, we use data sets which are small in nature, and to estimate various types of models and to find the relationships, we actually propose various sort of assumptions, various sort of restrictions. For example, the very famous statistic which we use to assess the goodness of fit of any model, which is the adjusted R-square. And when we start using machine learning algorithm, that adjusted R-square is no more, because there is no such degree of freedom problem. So we ignore that statistic, and then we only use the simple R-square formula. So the point I'm going to make here, like what actually we learned in the past in econometrics that might not be actually useful for machine learning. However, machine learning has its own limitation, because you cannot establish the clear-cut economic relationship, and it has low explanatory power, the machine learning algorithms. However, the prediction power is very much there in machine learning algorithms. But people like me, I have background of computer sciences, and luckily I also have a background of economics. So people like me, they always encourage to use hybrid approach. So the hybrid approach is, let's not rely on one sort of subject or one sort of domain, only pure econometrics, or maybe the machine learning side of the CS. But to me, the better approach is, let's think and classify the problems, and based upon the classification, we can use the beautiful version of classic econometric models vis-a-vis the beautiful version of the modern techniques of machine learning. So it's the right time to use hybrid approach. And similarly, in our academia, in the past, in our quantitative courses, we offer courses in the field of econometrics. We offer econometrics 1, econometrics 2, time series econometrics, Bayesian econometrics, various alternative subjects. But this is the right time to teach our students the machine learning stuff, and let's propose these data analytics new courses so that they can learn how to tackle the big data, and if they have in real time prediction problems, so they can use machine learning algorithms in a more sophisticated way. So for example, people in State Bank of Pakistan, so the main task is to formulate monetary policy, and for monetary policy the overall the framework is to use the forecast of various economic indicators like inflation, like the monetary aggregates forecast, like the GDP forecast, like the inflation and many other economic variables. So for forecasting exercises, I am also going to recommend for State Bank to use machine learning algorithms, and at the same time when we want to test whether if we increase some interest rate for some basis points, so what's the likely it has the outcome on economic recession in the economy. So there we need to explain the relationship. Then of course the classical econometrics model are very useful for that area. So for me, let's use both these things at the same time, and let's train our students so that they can use both approaches to address various real-time applications. In the end, we are training our students the economics, but at the same time we need to guide them how to use quantitative analysis in a more precise way. So that's my take to your question. Thank you.
Okay, thank you, Dr. Anna. Dr. Sajjad, my next question is from you. Like, if you see the Bloomberg, they have the tweets data and the public sentiment data, and they are using this data for judgmental forecasting to predict the trend in the stock market or bond market. Similarly, in UK and US, they are using the real-time consumption, tax collection, and government expenditure data to shape their macroeconomic policies like the fiscal policy and monetary policy. You are from the computer science, but they are using these machine learning methods and big data methods to see the effectiveness of their policies. Similarly, in China, I do not remember the dataset name, but they have social indicator dataset, and they are using it to predict the credit worthiness of the individual, like the bank should give him a loan or not. They are using that dataset, and it is just the individual Facebook data, Twitter data, how many times he has broken the signal and how many times he has made the crime, and what is from the credit card they see what are his expenditure, will he be able to repay the loan or not. How reliable are these forecasts, and up to what extent we can use these models in our country to see the effectiveness of. Like in the central bank nowadays, we are relying on the old models, like we are using mostly we are using the annual data, but nowadays sometimes we have, for some variable, we have the quarterly data. So what are the advices for the central banks and other agencies, Ministry of Finance, to use what type of models to see the effectiveness of their policy and to see the impact of their intervention very soon, not to wait for a year.
Okay, so being a computer scientist, I would leave the fiscal policy and public policy question for Dr. Adnan and Fatma. But to summarize, I think it all depends upon the technological advancement of a particular country, because before we decide to use these methods. So maybe in the UK and US, the prevalence of technology is of high proportion versus a country like in Pakistan. So I would say, like, if we start using all the text data available on social media platform for our policy making, then we might be dealing with a very biased data set. So just to give an example, if we just focus on a Twitter post. So maybe a political party may decide to conduct a Twitter poll to see how popular they are, but we know that Twitter is popular only among the urban class, and mostly among the youth. So if a party thinks that, oh, I got 90% poll result in a Twitter poll, then it doesn't reflect, it won't reflect the actual election result. Because in election, people from all background vote, not just the youth and the urban population. So there are going to be some implication if we solely rely on these social media platforms, or get input from social media platform and use the output for public policy or other policy. So that's one issue. Now, regarding how China is using these things, so there are going to be some, maybe China can afford this level of data intrusion or privacy intrusion, and no one is going to challenge them. But perhaps in more open countries, it won't be so easy that if you have committed a traffic violation and the bank say, okay, we cannot give you a loan. So maybe so there are certain insurance company even in the West that if you have, if you make certain traffic violations during a year, then it has an impact on your insurance premium, car insurance premium, because you seem to be a reckless driver, so we cannot offer you the best rate. So that perhaps makes sense, but doing a traffic violation and not getting a loan or similar things, I think this may not be applicable for all the countries in the world. So I would say, secondly, even in the West or in the UK and US, Twitter and other social media platforms, they are highly biased and they can be easily influenced. So all of us must have heard about bot, influencer taking money and popularizing a particular trend. So it's possible that if we want to make this conference very popular, we can go to certain influencer, we can hire an army of bot, they can keep tweeting about us, they can make certain hashtags very popular, but it may not reflect the actual reach of this conference. But on Twitter, it may become the top trend in Pakistan. It's possible. If we have the enough money, we can make any hashtag as one of the top trend in Pakistan or globally. So I would say, again, as I said in my earlier response, then I would offer a cautionary note that yes, these are very important things, but we need to consider all other aspects as well, which are more linked to public policy, and again they have an impact on fiscal policy as well, I guess.
Fatma, what are the tools for modeling the social networks? Which tool we use, and how these tools can be used in economics and finance to model the causal inferences? Can we use those social network models for modeling the causal inferences like econometrics or not?
Very interesting question. So just like in any other field, in network as well, we have two classes of models. So once we have a statistical class and we have a mathematical class, and both classes have their advantages and disadvantages. So when I'm talking about mathematical class, my primary objective is to ask whether the network that I'm observing, whether a trade network or any network, is it because of some random process or random nature, or just it happened just by chance, or is it because of economics and social norms and some phenomena? So when I want to ask this question from my data, I use classical random graph models, which fall under the category of mathematical models, mathematical class of models. So what I do, and I'm using classical models, I observe my network, I calculate the basic metrics, which I just talked about, the centrality, the number of communities, and degree distribution. So I keep it at a side. Then using those parameters, I generate a random network. That's the job of classical random graph models. I will assume that there's a probability distribution, I will give the parameters, and my software, whatever I'm using, will give me a random graph model based on those parameters. And now what I will do is, using those, that random model, I will calculate, try to see whether it has the same number of communities as my original model did. So if it doesn't, if it's something unusual, if those parameters don't match, then I can use that conclusion to state that there is something socially or economically different happening to form that model. So in that sense, the classical random graphs models are a baseline models, which I can use to further use the statistical class models. Now, under statistical class models, we have exponential random graph models, then we have latent models, we have stochastic block models, and they all have their uses. So the easiest one to understand is the exponential random graph models. They are basically extension of generalized linear models that we use in econometrics, which include OLS, probit models, logistic models. So in exponential random graph model, what I'm assuming is that the observed network is random, and I try to see whether it's linked with, for example, the number of edges that exist, centrality measures, and moreover, I can include for vertices attributes. What I mean by vertex attributes is, for example, personal characteristics of the nodes. So it's more intuitive to think of an example in international trade. So the world system theory tells us that the global trade is stratified into hierarchical group. We have a very tightly connected core and a weakly connected periphery. So in literature, we find that the trading patterns of cores differ from the periphery, and this leads to a power imbalance within the economy or within the country. So we can use exponential random graph models to model the export patterns of core versus periphery and see how they differ and whether they are contributing to the power imbalance that we observe in our world economy. Moving on about causal inferences. So when we're talking about networks, for example, we have a network of village and we want to see whether a technology is adapted quickly by a community which is tightly knit as compared to a community which is loosely knit. So in that sense, we can use the causal framework which we have for networks. So basically what we are doing we are not giving treatment to individuals, we are giving treatment to the entire network. And naturally when we have a network, the basic assumption we take of which we call the Sutwa assumption. So that is violated because of the interference that takes place between nodes. So in that case, to counter for that violation, we have network exposure models, which are very handy when we want to understand the effect of treatment to an entire network. So comparing the mathematical class of model and statistical class of model, they both have their uses. Statistical class of models are like built to fit data better than the mathematical class models. Mathematical class of models are very sound with mathematical foundation. But statistical class models are built to ensure that the model we can predict using those models as well. So more applications of what we have okay. So when we observe networks, the real world networks, what we find is small worlds and preferential attachment models. But classical models don't really capture those components of real world. So again, some models have shortcomings, and these exponential random graph models and like the latent models and the block models offer a solution to those shortcomings.
Okay, I want to add one more thing. We can use this social network model to see the interdependency among markets and between the countries and the spillover effect of the shocks. This is a wide application of the social network models in economics, and in many studies, these models are used to see how the trade blocks over the last 50 years have evolved over time. Do the gravity theory hold or not? In what time period the gravity theory holds and in what time period it doesn't hold? In literature, these social network models are used for this type of modeling. So I'm skipping some of the question and I am coming to you, Dr. Sajjad. And this is the most important question. What skill and knowledge and type of curricula are essential for the next generation of economists? And what changes should we bring in our curricula, particularly the empirical parts and the mathematical parts in our courses, to prepare our next generation of economists?
Okay, in fact, I wanted to ask this question, Dr. Adnan, because when he was describing the job market, and as a non-economist, I was also wondering that how much of curriculum is driven by the market demand, and how much is the pure thing that okay, we are economists, every student must learn this thing, whether there are no jobs or or a lot of jobs, we have to teach economist students these kind of stuff. So again, I would leave it to Dr. Adnan because I'm not an economist, but what I'm going to say is that technology, has always, at least for the last 20-25 years, technology has been an integral part of all the data analytics, driven subject, be it statistics, be it economics. Students have been learning about, SPSS, SAS, even eViews, all the other softwares. And now what we are seeing is not, sort of a revolution. It's just a gradual evolution that from SAS, SPSS, now we have moved towards more computing-based model, like where students need to learn programming. Previously, it was more, manual-driven programs, but they were doing the same task. Even Python is still doing the same task. But what we have done is we have added more set of algorithm, as Dr. Adnan was describing. Now we have machine learning algorithm as well as classical algorithm. And instead of using that manual-driven interface, now we are programming it because the requirements have changed. We have more data. So perhaps since the data is more, we cannot compute it on our local machine. So we need to store data on cloud and then connect our local machine to the cloud and do the processing there, because not everything can be downloaded. So these are the new things which are which have arrived because of technology. And so students, I would say these days must learn about, must learn R, Python, SQL, because again, because of the size of data set. But again, I would say these are not something which are revolutionary. Historically, students have been learning different other technology platforms, but these days, the focus is more towards programming-driven platforms. And, LLM, again, you didn't ask it, but, besides all the Python and other thing, large language models are going to stay as well. So everyone is going to use it, and even 5th grader and 6th grader are using it, but graduate, undergraduate students, university students, it is expected that they at least they are able to use them through programming. So even if you are solving a report or writing a report, doing a public policy discourse, at least should be able to do it in an automated fashion. So that would be the key, and this is why it's important that now all the curriculum should have very strong programming component built in it. But as far as the pure content, what should be taught in economics, what should be taught in health data sciences, I would leave it to the experts. Okay, sir.
So what are your opinion about this?
Since time is short, so I will be quick. So my take is like this is the right time. Dr. Asma is there, she's dean, she is going to decide the future of our whole school. So I would say, you see, those analytical courses, CS-based courses, machine learning-based courses are really important for not only for economics, but as well as the social science department. For example, we used to offer courses in history, and most of the historical archives data is there, and let's exploit those archive-based data to learn the historical patterns based on machine learning. And similarly, for example, I have also interest in theology and Islamic studies, and what right now I'm also doing a very interesting project, and I'm going to build a mufti which is called artificial mufti. And I'm going to use those fiqh-based rulings and try to use those rulings to learn various, for example, if I able to develop a chat box where a person maybe put a question to that chat box, okay, whether this thing is halal or haram in Islamic context, so that virtual mufti actually able to give the response based on the learning algorithm. So what actually our real muftis are doing, so machine will be doing that thing maybe in near future, and same is true for businesses application. So to cut short, to me, this is the right time to train our students, because I recently conducted a survey, market-based survey for especially the finance firms, accounting firms, auditing firms, especially in Karachi. And I was really surprised to see 90% of them actually, they are still using ad hoc, Excel-based calculations and old-fashioned type analysis. Now this is right, and there is a huge demand for them, and they are keep asking, why not you at IBA offer the training programs to train our sporting staff how to use modern things in our business applications. So this is the right time to train not only our students, but also our maybe people from private businesses as well as the public sector to use the modern things so that they can form their policies and in a more optimal way, in a more fashionable way. Because if you see, for example, if you open websites like Amazon, so for example, if you buy some item from there, so that Amazon basically provides you recommendations. So it means that some sort of algorithms are there, those are called recommended systems. So let's guide our businesses people, how can they develop these kind of tools to expand their businesses with the help of modern tech. So this is the right time to offer a BS program in economics and data sciences, as well as IBA should launch another program which is MS in accounting analytics, because accounting is the language of business, and let's train our accounting students how can use the modern data analytics in a more appropriate way to learn the accounting, which is the language of businesses, and maybe in future they can use this in our businesses and in our real applications.
Okay,
so that's my take.
Yeah.
And again, on a rather funny note, so I expect that we are going to see a war between virtual muftis of one sect against the other sect. So we will be hosting debates because it's a very interesting issue that Dr. Adnan has raised. But again, there are going to be challenges, not just in this domain, but anywhere. If we try to replace human beings, it's not an easy task. So as long as we are doing fun projects, that is fine. But because when it comes to new kind of question, these language models, these chatbots, they are not trained for that. So as long as we are doing repeated tasks, a question has been asked 100 of times, you ask the same question again, the chatbot or large language models, they would reply with certain level of certainty that this is the right answer. But if you throw up a new situation, then they are not going to give you the correct answer, because it's all based on the fundamentals of machine learning. They have been trained to reproduce that answer. Whenever you ask a certain question, they have been trained enough time that they are going to provide that particular answer. But if you throw a new question, and now they will, you can imagine anything that would come out of large language models. So again, I mean, the idea is noble, and it will produce result with certain level of accuracy, but it may not replace the job which humans are doing. So just want to add something that whenever we talk about language model, whenever we talk about technology, there are fairs, and I was expecting that we might discuss this thing, or in other sessions may have already discussed this thing, that how these technologies are going to impact the job market. Because, and again, as Dr. Adnan was pointing out, and it occurred to me that, yes, this is true, that if a person is involved in any repetitive task, then it's better to upgrade yourself, because these, things are going to impact your job market. So all the students who are sitting here and who are doing TA work, okay, I don't have a good news for you. Within 1 or 2 years, you will see that every teacher is going to have a virtual TA. So I think, in fact, right now it's so easy. We can do it in just a week time. So if I teach a subject, let's say machine learning, I put 5 or 6 books, I refer to regularly, and all my lecture notes into a chatbot, into a large language model based chatbot, and it will start answering a question only based on those books. So the general purpose chatbot, it will come, it will find information from all over the places, but I can force it to only find information from the book I have referred to. In fact, many technology savvy authors these days, they are also releasing their chatbot. So as soon as they publish the book, they say if you go to that particular website, my website, you will find a chatbot. That chatbot can explain the topics I have addressed in my book. So we will see these things more often. So again, I just want to add this thing. But it's a wonderful idea, and it's going to produce very exciting results.
We have only 5 minutes, and the floor is open only for 2 questions.
Zaurehman from Ghazi University, as discussed here, that econometrics totally based on assumption, and machine learning totally violated that assumption. Then you describe here that the prediction which are made by machine learning are very strong. When there is no foundation, what we have to do with prediction?
So I think if you just look at weather forecasting, maybe a person who has studied geography in depth, he understands the mathematical model, he say, okay, the wind is blowing from this direction, and you know the atmospheric pressure is this much, hence there should be rain on this particular day. But what if I give you data of, let's say, past, you know, thousands of years, and you start learning that you don't know anything about atmosphere. You say, okay, if this thing is true, then this is how it's going to happen, whether it's rain or not. If I give you more, so this is how machine learning models work. If you provide them enough data, they can learn the pattern without even understanding the theory behind it. I can quote you one practical example: the autonomous drivers. You know, where we have autonomous cars. So can I describe the way I drive? I think it would be very difficult. So I drive, you know, all of us drive every day, but can you tell me, okay, why when you were taking the right and what actually you were thinking? I cannot provide, you know, give you a crisp answer. So yeah, I look at the back mirror, you know, I saw there's no one beside me, but it will be always vague answer. But when you put sensor all across the car and it's recording the data continuously, so it comes up with a pattern, even which you don't know. So that autonomous driver, autonomous car, it doesn't know a lot of theoretical or background knowledge, but still it's able to do it, you know, drive it very, I mean, it's still doing a decent job, at least in California, other places where the permission has been given. It's not perfect yet, but if we compare the proportion of accident between autonomous car versus human driver, I would say autonomous car is still doing a better job.
Salim Khan from White. My question is about economic theory, and we have a glimpse from the Facebook that from reveal preferences they draw my preferences better than any model, even they know about me better than me, my choices that I make on the Facebook. So it is intriguing me if machine learning, if we back to 1970, 1960. So I don't think we start with the classical model, linear model. We should start from machine learning. So it's the time that we have a big data, because big data will be the future oil for all markets. So we should focus on infrastructure, not on the modeling. Modeling is there. We need infrastructure. We need real-time data. And for that, we are very behind it, lagging behind from the developing countries. So this is the problem. Real problem is the real data, the big data.
So the availability of data is very important, but data is available right now, and the responsibility also lies on Pakistan Bureau of Statistics in Pakistan, like these are sort of statistical agencies, to focus on these things. And I agree with actually this is less question but more sort of a comment. So, and I am totally agree with you in that.
I have an understanding that you guys support the use of AI, right? We are sitting in IBA and academic institutions. So how do you think that the AI use will impact the intellectual capabilities and the capacity of the student? And how you want to support the use of AI for students with practical examples? Given the fact that the broking institutions, it has a study, it says that the ChatGPT and most of the AI are politically biased because they are trained on the Western data, right? In the short run, you guys might, fix the problem, but it's a long run. What will we doing in the long run? Thank you.
I agree with you. You see, your point is valid because most of the researchers who involved in like OpenAI stuff and the ChatGPT, so they are primarily based at like Western countries. But again, the question lies on us: why we unable to develop such kind of things, especially in South Asia? So this is again the overall problem is there. So it is the right time. We need to work, and let's use our region and our knowledge, the accumulated knowledge, to develop those applications so that the element of bias will be reduced. So again, the challenge is on us. Let's not put critique on the West, and let's focus on ourselves so that, and let's train our young generation so that they can participate in that area. Yeah.
Even though I had so many questions, thank you for giving me a chance, but I was avoiding to ask because of time. But since Dr. Sajjad has been giving us example of car and AI, performing better, I was just thinking that there are various hindrances that I see even with this example. For example, if there is a car that is going and there is a situation that it is unavoidable to avoid an accident, and there are three situations: one kid is going on the road, one person is sitting in the car, and car itself. So this creates an ethical dilemma that whom should this automated system save? Either a person in car or that the person which is on the road. So I see a conflict in the sense that, for example, an insurance company may say that I don't want to claim this insurance, and then there are ethical arguments and there are other side of argument. So how you are seeing those when developing these technologies, because I think it is all about socio-technological system. No technology can be in itself something. We need a socio-technological and legal and ethical system. So how these technologies, in domain of these technologies, these discussions are going on?
So I agree with you. So there is no need for disagreements, and this is why ethics in AI is such a huge area these days. So every conference of AI has dedicated 2 or 3 sessions on ethics in AI. Even if we go back and read the newspaper of 2014, 2015, CS people combined with MBA graduates, they are good in making hype. So there was a hype around, having driverless car arriving in 2017, 2018, and drivers would be useless. In fact, Jeffrey Hinton, who is considered the godfather of deep learning and AI, he said, okay, in 2 years' time, I don't see any drivers. So people should switch their profession. But now we are still seeing there are drivers on the road. It was found it's not so easy. Even even if you get 98% accuracy, but the last 2% accuracy is the hardest to get, and it may turn out that it's impossible. So if you just look at the autonomous car landscape, Twitter pull out, Lexus pull out, Google pull out. So right now only Tesla is doing a lot of things, but all the other competitors, they realize it's not possible. So I was just giving autonomous car as an example how machine learning works and how human mind works, but it's not necessarily I would say positive example. That even with Tesla, if you don't blink for a certain proportion of time, it means you are sleeping. The car will stop. So we have autonomous car from Tesla, but they are not fully autonomous. They are semi-autonomous, that you have to be behind the steering, and you should be awake. So there is a sensor which is continuously monitoring your eyes blinking, and if the ratio is different, then it will stop the car. So I agree. So this is why I'm saying, everywhere where mission critical information or decisions are taken, AI is not going to replace human beings. So it's good to use AI when it suggests, YouTube, videos. We open our YouTube app and it has some suggestion. I would say most of the time they are garbage suggestion. If you just watch, how to cook biryani yesterday, today your timeline will be filled with Hyderabadi biryani, Bombay biryani, Karachi biryani. You said, okay, I just watched a single video. I didn't want to, do a PhD on biryani. But this is how recommendation work, but they don't hurt us. Okay, again, when we, start writing emails, I would say, okay, dear Dr. Junaid, it tries to complete the sentence. Maybe I was saying something else, but it just wrote, okay, I hope this email finds you well. I just, ignored that recommendation. It didn't hurt me. So there was AI in my email, there was AI in my YouTube, but it's not hurting me. But we cannot expect that we go to our Khan and there's an AI-based chatbot sitting there. He said, okay, I think you should go for knee surgery. You say, why? Why should I go for knee surgery? Because, there is an issue. On all the mission critical application, AI is not there. And I don't see it happening, but I'm nobody, honestly speaking. So there is a big divide at the top level. So the people who have got ACM award, which is considered as a Nobel Prize in computer science, even those people, they are divided. So just a few months ago, Jeffrey Hinton, Yoshua Bengio, all the people who got those awards, they wrote against the risk of AI and all these, deep learning based model. But at the same time, we have people like Yann LeCun, even Elon Musk, and they are saying, no, don't, try to emphasize or, overhype the challenges. So we are also reading, but I agree with your point. There are ethical dilemmas, and I also feel that AI is not going to replace human beings in mission critical application. Yes, but in non-mission critical application, again, as I was saying, for repetitive tasks, yes, it's going to happen. All of us are using text, a large language model for various purposes. My students' reports have gone better. Just 2 years ago, I used to spend so much time in correcting the grammar and the comprehension, but at least now they look better. At least the grammar part has been taken care of by these language models. Even for comprehension, all of has some question mark. So again, no conclusive answer.
Okay, thank you all. And we should finish here. Thank you.